Hello, my name is Carl Dempsey with .062 Electronics. Today I'm going to show you how to create the schematic symbol for a high pin count device using PADS logic. The part that we'll be building is a version of the Artix-7 family from Xilinx. This particular chip, known by its full name XC7A350T FFG1156, has 1,156 pins, and as you can see from the various images, is a complex device that requires a fair bit of planning before building the schematic symbol. This block diagram of the device gives us a good visual to begin thinking about how we want to create the schematic symbols. It looks like there are 12 I/O banks that are identical, so we will plan to use one common symbol for them. There also appears to be 4 GTP quad banks that might be able to share a common symbol. After reviewing additional documentation for the device, we determined that 11 symbols will be needed. Bank 0 is unique and requires its own symbol. Bank I/O can be used for 11 of the 12 I/O banks. Bank I/O plus is needed for the remaining unique I/O bank. GTP will be used for 2 of the GTP quad banks, while GTP plus will be used for the other 2 GTP quad banks. The remaining 6 symbols are needed for the various power and ground banks. Once the 11 symbols have been created, it's time to create the schematic part. There are 23 gates required to make this part. There's 1 bank 0, 12 I/O banks, 4 GTP quad banks, 1 ground bank, and 5 unique power banks. On the Gates tab within PADS Logic, add the 23 gates A through W and associate the symbols to the gates as shown. Now it's time to add the pin data. For a part that has 1,156 pins, it's just not realistic to start typing in the names. There's too much opportunity for error, and such a task would take a long time. Fortunately, PADS has a great feature called Import CSV. Before you can import a CSV file, though, you have to set it up. Here we are looking at an Excel file that we will use to create our CSV data. The data in the columns with the white text headers comes straight from Xilinx. There's a document titled 7 Series FPGA's Packaging, and it contains a section called ASCII pinout files, where you can download this Excel data exactly as it's seen here. The columns with the green text headers have been added. For the import CSV command to work, the CSV file will need a header just like this one. We will work with each gate individually, starting with gate A. I've sorted the Xilinx supplied data on the bank column and can see the first 23 pins belong to bank 0. In the rightmost column, called Sequence, I manually set the numbers from 1 to 23. Next, I manually type in gate A, undefined, and the number 0. Then copy these 3 cells all the way down for the 23 pins in this gate. The number field in the PADS data is just a straight reference to the pin field in the Xilinx supplied data. For the pin name that will show up on the schematic, I would like to see the pin number on the end. So I will use the Excel formula called concatenate to add an underscore and the pin number to the pin name. You can look at the formula bar at the top for an example. Repeat this process for gates B through W, and when you're done, copy and paste the columns with the green text headers into another worksheet and save as a CSV file. Back in PADS Logic, click on Import CSV and navigate to the saved CSV file. Your gate and pins data will be imported. Here's a look at a few of the symbols after they've been placed on the schematic. The pin numbers are visible, and you can see the modified pin names that have the underscore and pin numbers attached. Good luck with your parts creation and your design. Feel free to contact us if we can be of any help with your schematic capture, libraries, layout, or simulation.